Look around you. When you do, you're looking at matter. There are two things in the universe, energy and matter. So if something is not energy, then it's matter.
Matter is everything that's around you that you can touch. Anything that's tangible, you can touch it, then you can say it's matter. Energy would be things that are intangible, like the light from the sun. You can't touch the light from the sun. So that would be considered energy.
Even air is matter, since it has a small mass and is made up of tiny particles that take up space.
If you think about a tire, when you inflate a tire, okay, the tire gets heavier, so air has mass, right? And it certainly takes up space because you can see that it's inflating the tire.
The same thing is true for a balloon. When we let the air out of this balloon, the balloon deflates. That's because even though you can't see it, the air takes up space inside the balloon. Matter exists in three states: solid, liquid, and gas, depending on the combination of temperature and pressure around it.
All heat is are molecules moving. The faster something is moving, the hotter or the warmer it is to you. Okay? And so when water molecules aren't moving much at all, they're held into position, they're ice, and they're basically cold.
A solid holds its shape and has a fixed volume. That's because, like these students, the molecules in a solid are packed tightly together, giving the substance a definite volume and a definite shape. A liquid takes the shape of the container it is in, so it has a definite volume but not a definite shape. The shape of a liquid varies with the shape of its container. The molecules in a liquid can slide past one another. That's how the liquid can take the shape of the container it's in. It can form the shape of a circle in a round container and can take the shape of a rectangle in a rectangular container. Gases take the shape of the container they are in and can fill the volume of that container. That's because gases have no definite volume or shape. The molecules in a gas are the farthest apart, and they move freely around each other. When you spray a perfume bottle, the gas diffuses and everyone in the room can smell it, because the molecules of the gas move freely and quickly to fill up the space they're in. Changes in the state of matter are physical changes that are reversible. Gases can become liquid and some liquids can become solid depending upon changes in temperature or pressure. Then they can change back from solid to liquid, liquid to gas. Think of an ice cube. Water has a freezing point of 0 degrees Celsius at sea level on Earth. Since the temperature at which a substance both freezes and melts is the same, the melting point of the water is also 0 degrees Celsius.
When you take and heat the liquid up, give it more energy, those particles start to move faster and they spread out. The more energy they have, the more they spread out.
The temperature at which a substance changes from a liquid to a gas is the boiling point. Water boils at 100 degrees Celsius at sea level on Earth. And then there's a change that's called sublimation.
Sublimation is simply a phase transition where solid goes directly to gas without becoming a liquid. A good example of that is carbon dioxide, or dry ice as we know it.
This is sublimation. As you can see, the dry ice, a solid, goes directly from being a solid to a gas that looks like a vapor. We put the dry ice in a plastic film canister, snap on the lid, and turn it over. The dry ice inside turns directly to a gas. It sublimates and exerts pressure on the film canister. After a short time, the gas pops the canister off the lid. But dry ice can be dangerous, so never try this experiment at home. So when you think of sublimation, think of these students who started out packed together like molecules in a solid. Playing the role of molecules, they are sublimating, going from being a solid directly to being a gas. And that leads us to something to think about. Which is faster, a helium atom at room temperature or a speeding bullet?
Hello, I'm Shannon Lyles with today's special report on the practical applications of carbon dioxide. Joseph Priestley showed us how he discovered that adding carbon dioxide to water could create sparkling water, which we know today as soda. But there are many other uses for carbon dioxide in our daily lives. For one thing, carbon dioxide is used in fire extinguishers. Fires need oxygen to burn. Carbon dioxide works by depriving fires of that oxygen.
We have carbon dioxide extinguishers on the trucks. They're 20 pounds, and we use them typically for small Class B fires. The way they work is they displace the oxygen, which removes part of the triangle, the fire triangle, which once there's no oxygen, the fire can't burn, therefore the fire goes out.
We can see how it works by watching this demonstration, staged for us by Palm Beach County Fire Rescue Station 41. They have ignited a flammable liquid placed in this tray. And once the flames begin to rage, they step in with a CO2 or carbon dioxide fire extinguisher to put the fire out. Carbon dioxide doesn't work on all fires, though, because certain chemicals can burn without the need for oxygen. And carbon dioxide can't work on large house fires because it would be too difficult to smother the entire fire with CO2. And it would be dangerous because it could suffocate victims or the firefighters themselves. So, for the big ones, firefighters use water.
What water does, it removes the heat from the fire, which is also part of the fire triangle. Once you cool the product down, it no longer off gases, flammable gases, and the fire goes out, whereas the CO2 removes the oxygen from the fire, which actually feeds the fire and causes the fire to grow. So CO2 removes oxygen, no fire. Water cools it down, no fire.
Gardeners who grow plants and flowers in greenhouses have also found a productive use for carbon dioxide. Plants need 3 essential ingredients to grow: sunlight, water, and carbon dioxide. Greenhouses allow the energy of the sun to shine on plants, and farmers must also water those plants. But more and more farmers are also using machines that generate carbon dioxide to boost the amount of CO2 in their greenhouses.
Animals basically consume oxygen and give off carbon dioxide. Plants do just the opposite.
Plants consume carbon dioxide and give off oxygen. It's called photosynthesis. And when more carbon dioxide is added to the controlled environment of a greenhouse, the plants grow faster. That's called the greenhouse effect. And it helps us all survive as planet Earth revolves around the sun.
If we didn't have the greenhouse effect, we wouldn't be here on this Earth. The greenhouse effect keeps the temperature of the Earth relatively stable.
It does that by trapping the thermal energy of the sun to stabilize the temperature of Earth. It's like wrapping Earth in a blanket to keep the heat in, even as Earth rotates on its axis and parts of the planet face away from the sun at night. But too much carbon dioxide may not be a good thing, and that's why scientists are worried about what they call climate change. Carbon dioxide is created by combustion reactions like burning gasoline and other fossil fuels in our cars and even power plants. We drive so many cars and trucks and need so much electricity for our homes and businesses that scientists are concerned we may be making too much carbon dioxide in our atmosphere. That in turn would make our atmosphere warmer.
When the temperature of the Earth heats up, that makes the ice melt. And when the ice melts, it can change the levels of the ocean. So here in Florida, maybe if you live right along the coast, you might be underwater.
Remember, too, that warm water holds less carbon dioxide than cold water, as we saw in our experiments with soda. And warmer ocean water would act the same way. The oceans would have less carbon dioxide in them, and that could change the pH level of our oceans and affect the animals that live in them. And let's remember, too, that carbon dioxide is the key ingredient in the soda we like to drink. The carbon dioxide gives soda its fizz. It also makes beverages less likely to have germs. But also remember that soda has lots of sugar, so only drink it once in a while. And make a toast to Joseph Priestley when you do. I'm Shannon Lyles with this question: how would your life be different without carbon dioxide?